My name is Osa Gaius. I work at a company called MailChimp in Atlanta, Georgia. MailChimp is the world's leading marketing automation platform for small businesses. In addition, I help organize the Erlang and Elixir meetup, and I've done so for almost 2 years. This talk will proceed as follows. Generally, my idea here is to give you a historical analysis, or a genealogy rather, of functional programming, and present some ideas around increasing the success of functional languages. The talk will proceed as follows. First, we'll have a short introduction. Following that, we'll discuss what exactly I mean by genealogy. Then we'll explore the history of functional programming, and then wrap up with some thoughts on how to move forward. The idea for this talk emerged last year when a young man walked up to me after the Elixir meetup in Atlanta and asked me a simple question: why should I learn Elixir? I learned over the next few minutes that he was attending a full-time boot camp at General Assembly while working a regular job. He rephrased his question: why does functional programming matter? You see, he was learning Node.js, Ruby on Rails, React.js, Angular.js, and a whole slew of other concepts in just 12 weeks. He was sleeping very little, and on the nights when he wasn't working his regular job as a bartender, he was attending meetups like mine to learn and to soak up more knowledge. As I looked in his eyes, I realized how tired he was. I realized that his question was a bit more nuanced, though. His question really was, why should I spend the little amount of waking hours I have left to learn about this functional programming thing? I wanted to admonish him to understand why concurrency affects modern distributed systems. I wanted to tell him to go home and watch every single Rich Hickey video I could find, because those videos changed my life. But I also wanted to tell him how beautiful recursion was. But as I looked in his face, I realized that he was hoping, praying, just to graduate boot camp in a few weeks and get a job somewhere as a junior developer. More importantly, I realized none of my answers to him were non-theoretical. I fumbled through an introduction to distributed systems and then told him to just focus on learning Rails at a boot camp because most local companies in Atlanta were going to hire him for that. I went home exhausted and rather sad about my failure to defend my language of choice, my failure to defend functional programming. As I reflected on this, I realized that part of why I had a hard time was because I myself had forgotten why I fell in love with functional programming. You see, like many of you, I've spent the last few years doing functional programming professionally and using these techniques. From writing functional React on the front end to building back-end systems in Clojure and Elixir, I've had the privilege of being exposed to and enamored by functional programming. For that reason, I often struggle to offer a credible and non-circular explanation for why functional programming matters, and more importantly, why it matters today. You see, a sizable portion of the folks who attend my meetup are currently attending boot camps, like General Assembly, and they have a finite amount of time to learn how to write software and then quickly after that find a job. They attend the Elixir meetup, for instance, to look for something that would give them an edge when they go looking for jobs. So for them, a lecture on some functional abstract concept does not really provide them any use immediately. It actually confuses them a bit more, especially when they don't have context as to why these things matter. But just as I failed to defend Elixir, a fundamental presupposition of this talk is that functional programming to some level has failed, which is to say that we, the functional programming community, have failed. Failure, I suppose, stings by its very definition and declaration, especially at a functional programming conference. It hurts. However, when we look at the top 15 programming languages today, none of them are functional. When we examine language popularity using the TIBE index, for instance, functional programming languages consistently do not rank at all. We observe instead that languages like Java, Python, and even Ruby continue to flourish, as you can see on the graph here. Even more alarmingly, if we define success as the availability of jobs, as we see here, we can argue that functional languages, once more, have failed. As you can see here, in the last 2 years, functional languages do not offer the same number of jobs as Perl or PHP. So how can we in good conscience tell bootcamp students who are hoping and praying to find a job after graduating to actually learn these functional languages? Now, I am aware that we could, however, redefine success as quote-unquote breaking new ground in new research or introducing novel concepts. However, that thinking, while academically honest, strikes me as somewhat dubious in this conversation because it avoids the hard work of addressing why functional languages continue to lag behind in practice, that is, in industry adoption. In fact, the prevailing argument of this talk rests on the claim that functional programming fails precisely because of our incapacity to be attuned to the real-world performance of the languages we build and use. In other words, if we want things to change, we must be attuned to the mistakes historically made by the community. With that in mind, let's discuss the history of functional programming, or at least what I mean by genealogy. Most commentaries on programming language adoption, both in research and in industry, merely focus on individual language features, things like static typing versus dynamic typing. More even, these commentaries fail to attend to the socio-political issues at hand. They assume problematically that language adoption takes place in a vacuum outside the political. This fails to get to the heart of why certain languages gain significant popularity and others do not. I found that genealogy is a better method through which we can discuss adoption. Genealogy takes on two forms. First and foremost, it is an account of ancestry and of descent of a family or species. Secondarily, and more importantly I think here, genealogy, borrowing from Michel Foucault, is an analysis of the development of ideas or truth through history. For instance, take the question, why did the Java virtual machine become more popular than the Erlang virtual machine? From a sort of simplistic sense, we could sort of debate, the intricacies of which virtual machine is performance better, so on and so forth. But from a genealogical perspective, we must delve into the gray, into the politics of industry adoption, the stuff that gets kind of messy. Therefore, I would treat functional programming as a family of languages with different species, and this, I contend, will help us, develop a better approach to thinking about these things. With that in mind, let's look at the history of functional programming. The early period of functional programming begins in the early 1930s, at least as I define it, and lasts until the late 1960s. It all begins with Lambda Calculus. Lambda Calculus emerges in the 1930s, led by Alonzo Church's work. It is a system of mathematical logic for describing computation based on functions using variable binding and substitution. It is the common ancestor for all functional programming languages. In 1958, Lisp emerges as invented by John McCarthy. It is the first practical application of functional programming to language design. Or to borrow from C.K. Ewan's phrasing, Lisp is basically Lambda Calculus with a user-friendly appearance or syntactic sugaring. The next phase, I think, is interesting because Scheme's emergence in 1970 marks the beginning of a period that I classify as, quote-unquote, making functional programming practical. While still driven by academia, we see a dedication to taking the early ideas from Lambda Calculus and Lisp and making them more useful for programming work. This period lasts until the early 2000s. Scheme is notable because it took Lisp and ensured that it actually adhered to Lambda Calculus in a formal sense. In 1973, ML continues the process of building upon Lisp by adding static typing. It introduces the novel concept of pattern matching for function arguments, and pattern matching would thereafter become a de facto standard in most functional languages. In 1986, Erlang, the language that we're all here to sort of discuss and be focused on, emerges as part of an R&D project to create a language to build more reliable telephone switches. However, I think what is interesting is that early attempts were made to sort of modify or utilize ideas from Smalltalk and Prolog for concurrent programming. And Erlang is notable because it merges for the first time, in a strong way, these ideas from functional programming, either accidentally or intentionally, with ideas from concurrent programming. And this sort of innovation that's fundamental to Erlang will become sort of commonplace in other functional languages thereafter. Miranda emerges in 1986, or 1988 rather, and popularizes these ideas around laziness that we now see in the community. Haskell closes out the century in 1997. It borrows heavily from Miranda, especially the ideas around lazy evaluation, but merges those with some more ideas around strong static typing. The next period begins in the early 2000s, where we see a resurgence of interest in functional programming in a period that we can call the Renaissance. This period can be characterized by attempts to make functional programming useful within industry. We see language development being led not by university researchers or by industry labs primarily, but by industry practitioners. We see people inventing and building languages to solve real problems by compiling to other languages and other frameworks. It begins in 2004, I believe, with Scala, a functional language that runs in the Java virtual machine. Although it is sometimes considered object-oriented, and rightly so, it borrows heavily from Scheme, ML, and Haskell before it. F#, a direct descendant of the ML family of languages, was introduced in 2005 and built on Microsoft's .NET platform. In 2007, Clojure was released, running on the JVM also. It adopts the common Lisp dialect with regards to syntax and programming model and avoids some of the sort of trappings that Scala uses around object-oriented programming. In 2009, Akka emerges. Although not a functional language, I think Akka is important in the history of functional programming because it symbolizes a renewed interest in the intersection of functional and concurrent programming. This was an area, as we discussed earlier, that Erlang first opened and has become more important as web services continue to grow. We can think of projects like Microsoft Orleans or even LASP as attempts to continue to explore this intersection. In 2010, Rust arrives. It borrows heavily from Haskell's approach to typing with an emphasis on concurrency. Elixir arrives in 2011, adopting a syntax and community emphasis similar to Ruby, but is built and compiles to Erlang. 2012 marks the rise of Elm, another part of the ML family of languages. It compiles to JavaScript and emphasizes strong typing. It is early evidence of the continued desire for functional programming outside sort of the typical low-level systems or even web tier. It's more sort of focused on the front end here. And we see this trend continue in places like React, Redux, and even ClojureScript. So with this sort of history behind us, as we reach towards the end of the Renaissance period here, and we consider how to move forward, I think it's important to start with a quote from Joe Armstrong from the 2007 History of Programming Languages Conference. I think this quote is quite apropos. He says, "The rise in the popularity of the internet and the need for non-interrupted availability of services has extended the class of problems that Erlang can solve." I think this quote is interesting because, for one, it is true today that the industry is focused on building large, resilient systems that solve particular problems. Practitioners are looking for new and old tools to solve really interesting problems that emerge only at scale. The question then is, why are we not seeing a rapid rise in adoption of Erlang and other functional languages? Again, if you recall the graphs from earlier, we do not see functional languages in that list of top 10 languages, right? So despite the rise in these sort of new class of problems, we don't see a corresponding rise in the adoption of these novel languages. And I plan to explore this along two axes. The first is breadth versus depth, and the second is evangelism. With regards to breadth versus depth, functional languages have traditionally chosen depth over breadth. Language developers have chosen to emphasize and focus on niche features, i.e. currying or distributed messaging in the case of Erlang. This interplay is a delicate one because the result of choosing depth over breadth has been that languages have become niche languages. By definition, unpopular languages are niche languages, and the converse is also true. Take syntax, for instance. Most functional languages have a syntax that is foreign to the average working programmer. We see promise in the signs of newer languages like Elixir to attempt to overcome some of these hurdles and offer sort of a web-focused syntactic sugaring on Erlang. Put simply, the emphasis that is put on making these languages syntactically different, the less popular these languages will become by definition. The second area where depth has sort of been chosen is regard to the domains that these languages have been applied to. While popular in low-level systems, functional languages miss the opportunity to help shape the web. I think we can sort of look at Erlang as sort of a case in point here that I think is quite interesting. Erlang emerges in the 1980s before sort of the web, as we think of it, sort of rises to the forefront. And although languages like RabbitMQ and eJabberD are built on Erlang, the language itself did not take hold as a general-purpose web server programming language. If we trace the development, we see that Erlang emerges significantly before Java, significantly before JavaScript, Ruby, and even Rails. However, these languages sort of eclipse it with regards to being able to define how the modern web is built. We see promise in the case of things like Elixir, Scala, and Clojure, but these languages still must resist that desire to choose depth over breadth, and thus, by definition, become niche languages. The primary way I think to contend with this is to specifically and explicitly focus on expanding the domains that languages can be applied to. Borrowing from the Ruby and Java community, the aim should be to develop libraries and tools to solve hard business problems in diverse contexts. Ruby's emphasis on developing a diverse array of gems, quote unquote, that approach, that sort of approach different problem sets and solve them really well, helped propel its growth. Now we can argue, back and forth about whether or not gems are the right way to do computer science, but we cannot, however, discount their effect on Ruby's rapid growth. A similar approach, I believe, will ensure the adoption of functional languages can be justified at large companies of significant scale. Although challenging, we must consider whether building tools for ourselves primarily and other hobbyists may reach a point of diminishing returns. This is to assume, of course, that we have not already reached that point. Put differently, in what ways does this approach, right, where we build things for ourselves and we sort of build things for other functional programmers, shield us from the real problems that real companies have? I think this is something that is often missed with regards to the history of Erlang, is that the gift that Erlang had was Ericsson, a concrete problem space, concrete business domain to go after. And this, I think, is a blessing that maybe other languages do not have, and sort of leads them astray in many ways. Recall, I think interestingly that OTP was designed around a particular problem set and not just sort of an abstract library that was built for no reason. So I think finding these sort of real problems that need to be solved is the way that languages can kind of ensure adoption happens. The second axis that I want to kind of walk through is evangelism. I think evangelism is marketing, and marketing is evangelism. If we examine Java, JavaScript, Rails, and even a modern language like Go, we see that there's an emphasis by companies and the organizations that steward languages on promoting languages and building healthy communities around them. They almost treat the language itself as sort of a product that means, or service to be marketed to the world. The reality is that functional languages, in general, do not emphasize this, at least not to the extent that, let's say, Sun Microsystems and Oracle did with regards to Java. In the case of JavaScript, Netscape and the Mozilla were aggressive in promoting and ensuring the use of the language. Even in the case of Go, we see a significant emphasis by Google on promoting the language and making sure it becomes a de facto standard. This speaks to the fact that language adoption is not about technical features. It's a socio-political issue. As a meetup organizer, I'm familiar with this challenge. And for this reason, I offer sort of two challenges when it comes to evangelism. I think first, functional programming enthusiasts, all of us here, must exit the bubble. We must go to conferences and meetups that are not functional in nature, right? I think there's a great pleasure in coming and speaking to folks who share similar ideas and care about similar things, but we sort of must exit the bubble in order to actually spread the word. So for that reason, I implore you to go to meetups that are unrelated to Erlang or Beam and pretend to give a talk on their topic. And then boom, hit them with the truth. I use this strategy in Atlanta quite often, actually. I go to JavaScript meetups, and I tell them I'm going to give a talk about, React or whatever the thing is that they care about at this point. And then, halfway through the talk, I'm like, just kidding. This is actually how you build a backend in Elixir, and here's how processes work in Erlang. And for me, what I've seen is a rapid, increase in attendance at my meetups because people are looking for these sort of interesting ideas, and they encounter them in a safe space, their language of choice, JavaScript or Angular or whatever it may be, and then they get new interests in this interesting thing called Erlang that they never heard of before, and then they now have a reason to come to the meetup. More seriously, though, I think that the folks who need to be convinced that functional programming matters and that Erlang matters or that Beam matters, these folks do not currently attend the Elixir meetups. they attend other meetups or they stay home. And so they will never encounter the information unless we go to where they are. Maybe not their homes, but perhaps the meetups that they're at. Another approach, I think, for functional programming communities to take is to take a serious approach, as I mentioned earlier, to marketing ourselves. There's a particular sort of problem that I sort of sense, which is that, as people who build software, it's hard to think of ourselves as marketing people. But I think that's oftentimes what needs to happen. Because there are particular problems that the languages that we talk about and care about, particularly on the Beam, there's certain problems that these languages are designed to solve. And reaching out to companies and universities to provide guidance should be emphasized in addition to actually building the languages and tools. For instance, we know that Erlang is great at solving problems related to distributed systems. And so the community, all of us really should, as a service, offer our assistance, maybe even pro bono, to companies that are actually trying to solve these problems. This does not substitute the hard work that consultancies are also already doing, but sort of complements that work, and I think is part of the ongoing effort that's necessary. So by way of conclusion, the history of functional programming, I think, is not static and is always already political. The story of Beam is about taking ideas from other places like ML and Smalltalk and repurposing them to solve hard business problems. It is less about strict adherence to formalisms like Lambda Calculus and more about being part of a tradition of ideas and approaches to computation. We are at a unique point today, celebrating a bit early the 20-year anniversary of Erlang becoming open source. What I believe will define the next 20 years of Erlang, or what I hope really will define the next 20 years of Erlang and Elixir and the Beam, will be our continued openness to new and old ideas that help us solve problems. A continued openness to folks who are willing to listen despite their background, an openness to going to where people are, their meetups, to go talk to them. We may never achieve the perfection of Lambda Calculus, but I think we can maintain fidelity to the spirit of Lambda Calculus, which is really about a pursuit of excellence in computation coupled with simplicity. This is the essence of functional programming and what I believe will guide us as we move forward. Interestingly, though, I think we are also at another juncture. Software engineering as a sort of field was formalized 50 years ago at the NATO Science Committee Conference. We, the functional programming community, have a unique responsibility to software engineering as a field. The ideas around fault tolerance, safety, reliability, security that we sort of care about, especially on the Beam, are not nice language features. They're not sort of cool things that we can keep to ourselves. They are what society now demands of us as builders of software in the 21st century. Put simply, it's our responsibility to actually build software that has these things as constituent elements. Continue to blame the recurrent software crises that we see on bad programming models will not suffice and actually fall short. Because if software engineering is to become a true engineering discipline, we must ensure that the ideas that we hold dear in the functional programming community become widespread in practice. We must ensure that they become the de facto standard. And my hope is, that a decade from now, young programmers like my niece will not have to ask the question, "Hey, uncle, why does functional programming matter?" Because to her, the answer will be readily apparent, by the number of jobs, by the popularity of the languages, etc. But I think this will require hard work. But I think it's a challenge that I really strongly believe that this community and communities like this one can achieve. It will require organizing more meetups, buying more pizzas, giving more talks, even guerrilla talks, and sort of giving this all we have. Tell your friends about the Beam. Buy them Erlang books for Christmas or for their birthdays. Really, I implore you, I beg you even, because I think this is really that important. So let's go out there and do this, because we stand on the shoulders of giants, and we have sort of a responsibility to actually spread the message. And so let's make the next 20 years as great, and I dare say even greater than the 20 years that came before. Thank you.